valency bond theory in complex compounds. Complex compound are compounds of d block elements. So based on approaching way of ligand, if it is the metal and it is the ligand, in complex compounds, ligand donate pair of electrons to the center metal atom. By this, compounds exhibits some hybridization. Based on this content, the compound is in sp hybridization. It is linear geometry. Is in sp2 trigonal planar geometry, or is in sp3 tetrahedral geometry. It is in sp2d or dsp2, that is square planar geometry. If the hybridization is sp3d, it is a trigonal bipyramidal geometry. If the hybridization is dsp3, it is a square pyramidal geometry. If the compound is in sp3d2 hybridization, it is octahedral geometry. Octahedral or square plane bipyramidal geometry. If the d is used outermost orbit, that is outer octahedral geometry. If the two d orbitals are inner d orbital, it indicates it is n minus 1 d orbital, it is n d orbital. If it is d2 sp3 hybridization, that is inner octahedral geometry. Inner octahedral geometry. So it is the hybridization of the molecule and their geometry. Hybridization and geometry of diamino silver chloride complex. In this complex, primary valency is oxidation state. For oxidation state, you have to calculate silver oxidation state. It is X plus 2 amine ligands are there. Each amine ligand charge is 0 and plus 1 chlorine is there. Chlorine charge is minus 1, then total is equal to 0 because the complex has no charge. And then X is equal to, this minus 1 will going outside of the equation, then it is plus 1. Primary valency in the complex is its oxidation state. And secondary valency is the coordination number, that is the number of bonds taken by ligands. Here 2 amino ligands are there. Each amine makes one bond. That's why 1 into 2, and it is a monodentative ligand. This chlorine is ionic sphere. It is not a ligand. Not ligand. Ligands are represented within the square bracket except central metal atom. Remaining all the compounds in the square brackets are ligands. Here 2 ligands are there and that is ammonia ligand. It donate one lone pair to the silver, it can makes one bond, then totally two monodentate ligands, 2 into 1 is equal to 2. This compound primary valency is +1 and secondary valency is +2. And next, hybridization of this molecule, complex compound. For hybridization, silver valency electronic configuration is 5s1 4d10, 5s1 4d10. It is in +1 oxidation state. It indicates one of the electron in s orbital will lose, then it has 4d10 5s0 electronic configuration. In this state, the inner 4d orbital has 10 electrons. They are completely filled with electrons. It is the 4d 10 electronic configuration, and there is a one s orbital, that is 5s in empty state, and another fifth orbital has 5p orbitals, and px, py, pz are in vacant state. In this complex, NH3 act as a ligand. Ligand donate one of the pair electrons to one s orbital, and another one ligand donate another pair of electrons to p orbital. For this formation of complex, the silver metal has used only one s and one p orbital. It indicates it is in sp hybridization. Compound is in sp hybridization. Geometry is linear geometry. And bond angle is 180 degrees in linear geometry. In the formation of complex, number of unpaired electrons is equal to 0. Then magnetic moment mu is equal to square root of n into n plus 2. Here n is number of unpaired electron after formation of this complex. After formation of this complex, it has no unpaired electron, then n value is 0, magnetic moment is 0, then it is diamagnetic. And there is no change in 4d electronic configuration, then it is high spin complex. It is the hybridization of AgNO3. Hybridization of triiodomercurate ion. For this complex, primary valency is oxidation state. We have to calculate oxidation state of mercury ion. Mercury oxidation state is X, then 3 iodides are there. Each iodine charge is -1, is equal to, this complex has a -1 charge. Then x minus 3 is equal to -1, x is equal to -1 and +3. Finally, mercury is in +2 oxidation state, that is its primary valency. Secondary valency is coordination number, that is number of bonds taken by mercury in this complex. Here iodide act as a ligand. It can take one iodine, one bond to the mercury, and it is monodentate. Therefore, number of monodentate into 1 is the coordination number. Here 3 monodentate ligands are there. Each one makes one bond. Then secondary valency is 3. Then hybridization of this molecule. Mercury valency electronic configuration is 6s2 5d10 and mercury is in +2 oxidation state in this complex. +2 indicates 2 electron lost by the mercury, that is from outermost electronic configuration. It indicates you have to remove 2 electron from this electronic configuration, and that is valency orbital. From the valency orbital, then it has electronic configuration 5d10 and 6s0. It is the 5d10 orbital representation. D has 5 subshells and each subshell has 2 electrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is the 5d10 electronic configuration. After 5d10, 6s orbital is empty state and 6p orbitals also in empty state. There is 3 iodine ligands. Each iodine donate one of the pair electrons to the mercury vacant orbital. Then it has one s and 2 p orbitals involved in this hybridization. Then it is sp2 hybridized. Hybridization of this molecule is sp2. Geometry of the molecule is trigonal planar. Bond angle in trigonal planar is 120 and n is equal to 0. Here n is the number of unpaired electrons in the formation of this molecule in mercury. Then magnetic moment mu is equal to square root of n into n plus 2. Here n value is 0, then mu is 0. It indicates it is a diamagnetic complex. And it is high spin complex. There is no change in 5d electrons before formation and after formation of this complex. That indicates this molecule is high spin complex. It is the hybridization of Hg(I3) minus ion. Tetrachloronickelate ion. Its primary valency is oxidation state. Nickel has X value. 4 chlorines are there. Each chlorine has -1 charge. Then complex exhibits -2 charge. Then x minus 4 is equal to -2. From this, x is equal to +2. Nickel is in +2 oxidation state. Secondary valency is the coordination number. And here 4 chlorines are there. Each chlorine is monodentate. Then 4 into 1. Here 4 indicates number of chlorine ligands. And 1 indicates each chlorine makes one bond, that is monodentate. Then 4 into 1 is equal to 4. For this complex, primary valency is oxidation state +1 and secondary valency is coordination number 4. And next, hybridization of this molecule. Nickel is 4s2 3d8 electronic configuration. And this molecule nickel is in +2 oxidation state. It indicates 2 electron loss from valency s orbital. Then it has 3d8 and 4s0 electronic configuration. And 3d8 d subshell has d orbital has 5 subshell and its electronic configuration is 3d8. It indicates 8 electrons in d orbital. 1, 2, 3, 4, 5, 6, 7, 8. and s orbital is in empty state and p orbitals also in empty state. There is a 4 chlorine ligand. Each chlorine donate one of the lone pair to the 1s orbital and 3 p orbital. Formation of this molecule, nickel used 1s and 3p orbital, 1s and 3p. Finally, it is in sp3 hybridized. Hybridization of tetrachloronickelate ion is sp3. Geometry is tetrahedral. Bond angle is 109 degrees and 28 minutes. Here n value, n is equal to number of unpaired electron. After formation of this complex, nickel has 2 unpaired electron, then n is equal to 2. Its magnetic moment is equal to square root of 2 into 2 plus 2. Then its value is 4 into 2 root 8. It is nearly 2.8 something. And it is a paramagnetic in nature. Paramagnetic. This complex has 2 unpaired electron, magnetic moment 2.8. Due to 2.8, it is a paramagnetic nature. And before the formation of the complex, after formation of the complex, nickel plus 2, a valence electronic configuration, these cannot paired. So then it is a high spin complex. It is a high spin. You have to check the spin capacity before and after d orbital has the same electronic configuration, then it is a high spin. If the electronic configuration is changed, then that is in low spin complex. Tetracyanonickelate complex. Primary valency of this complex is oxidation state. Nickel is X and 4 cyanides. Each cyanide has -1 charge. Then complex has -2. Then X minus 4 is equal to -2. X is equal to +2. Nickel is in +2 oxidation state. Secondary valency is coordination number of bonds taken by the central atom. Each cyanide ligand is a monodentate ligand, then number of ligands into 1 is the secondary valency. Its secondary valency is 4. Tetracyanonickelate complex has primary valency 2 and secondary valency 4. Hybridization of this molecule. Valency electronic configuration of nickel is 4s2 3d8. In this complex, nickel is in +2 oxidation state, then remove 2 electron from 4s orbital. It has 3d8 4s0 electronic configuration. In this state, the compound is obtained. 3d orbital has 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And 4s orbital in empty state, and there is a 4p orbitals, 4s and 4p is in empty state. Here the ligand used is a strong field ligand. Then Cn is a strong field ligand. In the presence of a strong field ligand, this unpaired electrons pairing takes place. Then pairing of electrons taking place in this molecule, this electron is paired in this position, then it has one d orbital is empty, and again 4s orbital and 4p orbitals in empty state. Due to availability of 3d empty orbital, one of the cyano ligand donate pair of electrons to inner d orbital, and there are 4 ligands. One is used in d orbital and remaining 3 are donate electrons to one s orbital and 2 p orbitals. Then it is dsp2 hybridization. And final conclusion is this molecule is in dsp2 hybridization, that is square planar geometry, and pairing of electrons takes place. N value is 0. It is the before formation of complex and it is after formation of complex. In this compound, after formation of complex, there is no unpaired electron, then N value is equal to 2 and mu also 2. It indicates it is a diamagnetic nature. And let us see, it is before formation of the complex, it has 2 unpaired electron. After formation of electron, the formation of complex, there is no unpaired electron. It indicates it is low spin. Before 2 unpaired, after there is no unpaired, that indicates the low spin complex. Low spin. So spin, if it is high spin, there is no change before and after, then that is high spin. Before formation and after formation, electronic configuration of d orbital is changed, that represents low spin complex. And final conclusion is tetracyanonickelate ion is in dsp2 hybridization, square planar geometry, magnetic moment 0, diamagnetic and low spin complexes. Let us see this compound. And primary valency is oxidation state, nickel value is X, and carbonyl ligand, it is a neutral ligand, it has no charge, then 0 into 4, and there is no charge in the complex, final value is equal to 0, totally X is 0. Primary valency of nickel in tetracarbonyl nickel complex is 0. Secondary valency is coordination number. Each carbonyl ligand donate one pair of electrons to nickel, then it is monodentate. Number of ligands is 4 and each one makes one bond. Secondary valency is 4. Primary valency is 0, secondary valency is 4 for tetracarbonyl nickel ligand. And hybridization, nickel is in 4s2 3d8 electronic configuration. Nickel is in 0 oxidation state. There is no loss of electron in 3d8 and 4s2. And it is the 3d orbitals. It has 5 subshell. Each subshell has electrons. That d electrons are substituted 8 electrons in the representation. And 4s orbital is in empty state and 4p also is in empty state. Here CO carbonyl ligand is also a strong field, then pairing of electrons takes place. It indicates d orbital is empty. This unpaired electrons pairing takes place in the presence of a strong field. In the strong field ligand, one of the d orbital is in a vacant state and 4s and 4p orbitals also vacant. This ligand donate one of the pair of electrons to the d orbital and another 3 donate 1s and 2p orbital. The orbital used in this complex is dsp2. Final conclusion is hybridization is dsp2, geometry is square planar, and n value is 0 and mu is 0. It indicates diamagnetic. And observe the before formation and after formation of the complex, there is a change in d orbital electrons representation. It indicates it is low spin. Change is observed, low spin. No change, high spin. Tetraamine zinc plus 2 complex. Primary valency is oxidation state. Zinc value X, 4 amine groups, each amine is 0, complex has a plus 2 charge, then X plus 0 is equal to plus 2, finally X is equal to plus 2, zinc is in plus 2 oxidation state, it is its primary valency. Secondary valency is a coordination number. It indicates 4 amine ligands are there. Each amine makes one bond. Then prime secondary valency is 4. And hybridization of the zinc in this complex is zinc electronic configuration is 4s2 3d10. Zinc is in plus 2 oxidation state, indicates loss of electron from 4s orbital. It is 3d10 and 4s0. In this state, the complex is formation takes place. Zinc has 5 subshells and each one orbital is paired with electron, that is 3d10. 4s and 4p orbitals are in empty state. There are 4 amine ligands. Each amine donate one of the lone pairs to one s orbital and 3 p orbitals. Then its hybridization is 1s and 3p. It indicates sp3 hybridization, tetrahedral geometry, bond angle 109 and 28 minutes, n value 0, dipole magnetic moment 0, and diamagnetic. There is no change in electronic representation. It indicates this is high spin complex. This is the tetraamine zinc plus 2 complex hybridization, magnetic moment, and the